Hello everyone, my name is Tjon-Joek-Tjien. I'm a master's student in computer science at the Vrije Universiteit of Amsterdam, and I'm here to present the work that my colleagues and I conducted. We have created a method to measure the performance of online video conferencing systems such as Zoom and implemented it as an automated tool. We think this is important because since COVID-19 has impacted society, we have seen a shift in more online meetings taking place using these systems. Using the automated tool, we gathered preliminary results, which we will show today with some interesting findings. Using the bit.ly link at the bottom, you can read our article, which is EEVCS. Especially now with this pandemic situation around the world, the usage of these systems has increased drastically. The main problem that we encounter is the fact that these type of video conferencing systems do not have enough publicly available information about their performance during usage, such as their CPU usage and also the bandwidth usage. This is a problem because if the performance of these systems is known to the users, they can decide which video conferencing system best suits their needs. Therefore, we have decided to create a tool to capture this data and analyze it. We focused on Zoom, Microsoft Teams, and Discord because these are some of the most used video conferencing systems nowadays. Zoom has over 300 million active monthly users, and Discord and Microsoft Teams both have over 100 million active monthly users. Our main contributions are the following. We designed a method for comparing video conferencing systems and implement it as a tool for real-world experimentation. Our method considers various communication channels such as audio, video, or both, different types of networks such as Ethernet, Wi-Fi 4, Wi-Fi 5, and 4G, and different experiment sizes such as one-to-one and an entire classroom. Our second contribution is a real-world evaluation of the three video conferencing systems, Zoom, Microsoft Teams, and Discord. And lastly, we evaluate them using 4 different experiments and analyze system and application level performance metrics. And we share our results on Zenodo. Video conferencing systems such as Zoom, Teams, and Discord differ in many aspects, such as their architecture or how the traffic is routed. To facilitate the design of a method to experiment across multiple video conferencing systems, we propose a high-level method of the operation of a video conferencing system. Due to the lack of publicly available information, this model focuses on the client side and does not detail how the server operates, which is typically inside the data center. So all of this we do not really know, and this is out of our control. So the model considers 2 main roles, which is the sender and the receiver. The sender has an input feed and an encoder, which encodes the data. And the receiver has a decoder, which decodes the data and therefore gets an output feed. And our measuring tool focuses on these components right here. Also, the encoding and the decoding is video conferencing system specific. So this is specific software each video conferencing system uses. The method we defined to analyze the video conferencing system consists of different clients over the network, where one is also running our measuring tool. We use the input feed as the benchmark workload, which helps us to design different experiments that are also reproducible. And the metrics our measuring tool captures are CPU utilization, network bandwidth, and the number of packets and packet sizes sent and received. We defined 4 major operational aspects in our method that are the regular operation of a video conferencing system, namely channels, the throttling, that is the network limitation of these systems, scalability, in other words, testing under large workloads, and different connection types. For each of them, we designed specific experiments in order to exploit their operational properties. The channels experiment captures regular operation of video conferencing system with various input channels. So this is the audio, and video. All other experiments use audio and video workload. The throttling experiment lowers the bandwidth by 50 kilobytes per second every minute from an initial limit of 500 kilobytes per second. 500 kilobytes, sorry. On the different connections, we compare Ethernet connection against Wi-Fi 4, Wi-Fi 5, and 4G LTE. And the scalability and different connections experiments are performed only on Zoom. The last part of our method entails our tool, which is a command line tool written in Python using PyShark. Each experiment is conducted using a PC equipped with a Ryzen 7 2700X CPU with 8 cores and 16 gigabytes of DDR4 memory, which is representative of consumer laptops or PCs. The wired connection is Ethernet-based, with the machine connected to the internet via a KPN network, which has 100 megabits per second download bandwidth and 10 megabits per second upload bandwidth. The wireless connections use a high-quality AC1715 Wi-Fi router and use the same internet connection. And the 4G LTE connection carries through KPN, which is considered a high quality provider in the Netherlands. All experiments maintain the default video and audio settings for all systems under test, and the video resolution defaults to 1920 by 1080. The basis of each workload consists of, for video only, a video with a duration of 2 minutes and 36 seconds played in a continuous loop. For audio only, an audio stream generated by turning on the public radio and recording this using a microphone, which in our case was NPO2, the NPO2 radio channel. And for audio and video, we use both of them combined and looped. These are all real-world fragments, and workloads combining them are realistic and reproducible. Here we see a box plot of the resource consumption, which is measured by the average number of CPU cores used. Discord is a very popular tool and the only open source video conferencing system in our test. But Discord also has significantly higher resource consumption when compared with Zoom and Microsoft Teams. This suggests that using Discord is not a great idea if an alternative exists. Here we see our classroom experiment. This is a real-world scenario, the largest in our test, which was a lecture at the Vrije Universiteit of Amsterdam conducted on Zoom. What we gather is that increasing the number of participants and video streams introduces high performance variability. In plain English, things work well for a bit, and then they might not for a little bit. The performance might, start to vary. And then again, it might work well for a bit. The presence of as few as several tens of classroom attendees can already start to make the performance unstable. Although we could only measure this for Zoom, anecdotally, we saw the same thing happen for others. So we conjecture that it applies to all current video conferencing systems. Also, anecdotally, we experienced crashes. We did not do experiments regarding reliability because they are very difficult to set up and control, but we did experience some crashes. Overall, the presence of performance variability is not good news for our ability to deliver courses online or for the idea that we might have many students engaged visually in the classroom. These are also some of our interesting findings. Using wireless connections, regardless of whether we use Wi-Fi 4, 5, or anecdotally 6, or maybe even a 4G LTE hotspot through our smartphone, these all lead to much higher performance variability than using a wired connection. This suggests that you should use wired connections if you have access to them, even if it may seem less convenient to work on a wired laptop while on the couch. In specific settings, Microsoft Teams consumes less bandwidth than its competitors. So if bandwidth is limited, then, for example, if you share the same network with your partner and both of you need to work online at the same time, it may be a useful tool. To conclude, we designed an experimental method to analyze and compare video conferencing systems such as Zoom, Microsoft Teams, and Discord. As shown by the results, the method allows us to compare the resource consumption of video conferencing systems in settings with different properties like the number of participants or different input feeds. Also, increasing the number of participants and video streams introduces high performance variabilities while conducting meetings. And from the results, we see that Discord uses significantly more CPU utilization and bandwidth compared to Teams and Zoom during video streaming.